Hello all, I'm Yogesh Gupta. Today I'm going to present my Data 670 data analytics project, credit card fraud identification using SAS Enterprise Miner. This is for UMGC's 2023 spring semester project. The data analytics problem that I'm analyzing is credit card fraud detection using deep machine learning algorithm. Credit card fraud is easy target and increased recently due to more online transactions, so that risk as well. There is a requirement to use different ML techniques to analyze the fraudulent and non-fraudulent data, and also design model which can be used on transactions, data collected from customer, and help future analysis. Here is some background. As per the Nielsen report, over last 5 years, losses due to credit card is reach up to 43 billion, and it is expected to go up to 408.5 billion in next 10 years, which is a huge problem, isn't it? So there is a need to build predictive model. After building, compare the model and identify the best model for the solving our problem. That's a problem we are looking at it. Some of the background. Credit card fraud detection is a well-studied problem in the field of machine learning. Many researchers have used various data sets to train and test models that can detect fraudulent credit card transactions. Researchers have used a variety of machine learning techniques to analyze this dataset, including decision tree, random forest, neural networks, and SVM. These techniques have been used to identify patterns in the data that can be used to predict fraudulent transaction with a high accuracy. Overall, the research in this field has shown that machine learning technique can be effective in detecting credit card fraud, but more research is needed to improve the robustness and generalization of these models. There are many other individuals who have tried to solve the problem by using programming language such as Python, R, and use various methods to identify or predict fraudulent transaction. But rarely anyone has used so far SAS to solve the same problem. I'm going to attempt to solve the credit card fraud problem using SAS Enterprise Miner. This will help fill the gap for the final accuracy for finding the fraud in the credit card transactions. There are few gaps that I observed with the credit card fraud detection project, and few are listed here. Here, one of the gap is that lack of robustness in the model developed for credit card fraud detection, as they may not be robust to change in the distribution of the data. Then the problem of generalization in the models, as they may work well on specific data set but may not work generalized well to other data sets. Then the third problem which we see is the limited number of data set is also a big problem. Uh, as most of the studies were done on a single data set, and therefore it is not clear how well this model will perform on other data set on the real world setting. And in fact, I also have a model which is one of the model which I've seen, and there are very few more other models for the analysis. Finally, then another gap which is limited features or feature set used in train and test model, which may not be sufficient to capture all the necessary information to detect fraudulent transaction. In addition, the credit card fraud data sets are often highly imbalanced with a small number of fraudulent transaction compared to the large number of legitimate transaction, which can make it difficult for machine learning models to accurately detect the fraudulent transaction. Important projects, why we are reviewing it. We've seen that there is a great importance to solve the credit card fraud issue due to following reasons. Number one, which is financial loss prevention. So credit card fraud can result in significant financial loss for both the card issuer and the card holder. A successful fraud detection and identification project can help prevent such losses by detecting fraudulent activities in real time and taking appropriate measure to prevent further damage. The second problem that we see is trust, customer trust. I mean, credit card fraud can negatively impact customer trust in the financial situation and the issued card. By implementing the robust fraud detection and identification project, financial institution can demonstrate their commitment to project and also their protecting their customers' financial information and transaction, thereby enhancing customer trust and loyalty. The compliance with regulation, that is another important problem which we can address. Many countries have regulations in place. The required financial institutions to implement measure to prevent the data. The credit card fraud often involves the implementation measures to prevent and detect credit card fraud. A successful detection and identification project can help the financial institution comply with this regulation and avoid penalties. And the fourth problem that we see is data protection. Credit card fraud often involves the theft of sensitive financial information such as credit card numbers and account password. A successful fraud detection and identification project can help protect this information and prevent it from being used for unauthorized transactions. Uh, there is a list of KPI that I see will be required for the successful completion of the project. Number one, the project task completion as per the initial project plan. One important KPI for this project would be completion of project itself. This could include milestones such as the completion of data collection and cleaning, the development of testing of fraud detection model, and the implementation of the solution in production environment for 100% on target. This KPI will going to help ensure the project is progressing as planned and that all the necessary work is being done in timely manner. The second indicator, which I've divided into two parts, first one is accurately identify the fraud detection in credit card transaction by using the machine learning model. Another KPI, which is project, would be the benefit of outcome of analysis. This could include metrics such as number of fraudulent transactions detected with the minimum accuracy between 90 to 99%, the dollar amount of fraudulent transaction prevented, and the number of false positive, which is nothing but legitimate transaction incorrectly flagged as fraudulent. This KPI is going to help ensure that the analysis is providing meaningful insight and the solution is effectively uh, corrected. The second problem, which is model performance. This could include metrics such as accuracy, recall, precision, F1 score, and AUC or ROC. Accuracy, and then again the sensitivity and specificity. This KPI helps to ensure that the model is performing well, and it could be used to evaluate the performance of different models during the development process and also to evaluate model performance over time. This can include reducing the false positive rate with the threshold value between 1 to 10%. And the last indicator or third indicator which I see is here is identifying the fraud in credit card transaction to help the customer avoid losing their money. This KPI for this project is mostly related to benefit of the outcome related to the organization. This could include metrics such as decrease in customer complaints, related fraud, the increase in customer satisfaction and trust, and the decrease in financial loss due to the fraud. This KPI helps to ensure that organization is realizing benefit from the working being done and the solution is effectively addressing the problem of credit card fraud. Threshold for this KPI depends on specific goals and budget of organization. And this can be measured, but post the successful deployment, even in the production stage. Okay, let's go ahead and see the data sets itself. So here is the data set that I would be using for credit card fraud detection prediction. For the credit card fraud detection project, there are multiple data sets available on the different website. The dataset was collected and donated by a machine learning group, MLG, at the ULB, which is university. The data was collected from the European credit card issuer in September 2013, and it contains transactions made by credit card in 2 days where hundreds of frauds out of many transactions were detected. The data was anonymized and contains information such as time of transaction, amount, anonymize features for the data. The data was collected as part of the research project and was made publicly available for use of machine learning and data analysis project. The data was collected using automated data extraction method from transaction logs and databases of the credit card issuer. So that's about the database. Let's look at what the data itself looks like. So if we look at in the table here, there is a snapshot in which we can see that we have around 492 frauds out of 284,000 in 807 transactions. The data set is highly unbalanced. The positive class, which is nothing but fraud, accounts for almost only 0.172% of all transactions, which is quite low. It contains only numerical inputs variables, which you can see here, where these are due to result of PCA transformation. Unfortunately, due to confidentiality issue, we cannot provide the original features and more background information about the data, such as feature V1, V2, and V28 are principal components and obtained from PCA. The only feature which have not been transformed with PCA are time and amount. Feature time contains the second elapsed between each transaction and the first transaction in the data set. The feature amount is the transaction amount. This can be used, for example, dependent cost sensitive learning, and feature class is the response variable and it takes value 1 and 0 between fraud and otherwise transaction. So given the class imbalance ratio, uh, I recommend measuring the accuracy using area under the curve, and confusion matrix accuracy is not meaningful for unbalanced transactions. Here is the data actually when I plotted with the help of Tableau. You can see data here out of 284,807. There are distinct count for 492 fraudulent transaction, and then unique value of the target variable is between 0 and 1, where 1 is for fraudulent transaction and 0 is for the non-fraudulent transaction. And the second graph, you can see the data is very imbalanced. The values are ranging between negative side and positive side of the graph. Some of the lessons learned that I've listed here, which can be helpful. Uh, so first one, which is business problem. The importance of the understanding the business problem and goals of the project in order to design the effective solution. That's one of the lesson learned. The importance of understanding the distinct types of fraud and the patterns of characteristic associated with each type. That's a second problem that I could see here. Uh, then the lesson related to data set and data quality are also very important. We see that high importance of obtaining the high quality and the relevant data for the analysis is very important. Then there is a data cleaning and pre-processing in order to prepare the data for analysis, also key point. Working with large and complex data set is another lesson learned. Looking at, you see the number of transactions that you see, it's quite huge, and then working with that is very important. Then, and again, the relationship between the various variables, which is very important for the data set and data quality lessons. Then the third lesson which we learn is the model development itself. So developing uh, considering and developing the robust model is another lesson that we learn. The importance of developing robust and flexible fraud detection model that can adapt to changing patterns and characteristics of the fraud over time, that's important. Then the understanding how the different variables will impact uh, the cause and the help provide the insight of the analysis, that's another lesson. Then the fourth and final lesson which we see is the visualization. Visualization plays a very important role on detecting how important is the identifying the right data analysis technique and visualization mode so that it can show the right result and predictability of the data. The next steps which I see from here onwards is listed on the slide. The first one is model building. Although there is some amount of work is already done, but using the selected feature, building the predictive model in the SAS miner to detect credit card fraud, This model will use statistical algorithm to identify pattern in the data set and indicative fraud. The second step which we'll do is the model evaluation, and which will help evaluate the performance of the predictive model by using metrics such as accuracy, precision, and recall and F1 square. The third step which I'm going to do is data visualization with the help of Tableau, where I load the results of the predictive model back into Tableau and use it create visualization, which can help communicate the result. And this could be like scatter plot, bar chart, or any other heat map. And I'll look at once I make some progress while developing the model. And the fourth step, which will be presentation of the results. So of course the SAS Enterprise Miner and the Tableau will help me create this dashboard, which will summarize the result and the analysis which can be presented. Sorry. The final slide, which shows the various references that I've taken to analyze the data and also the studied problem area, and going to help me future analysis in this project.